Okay, so for this diagram, let this be the force. Okay, and this is center, and distance between both of them is 20, and this is B, this is A. So what is the distance between B to A? 50. And the first question, calculate the resultant moment of at point A. So at point A, the distance between these two, point A, is this and this. So at point A, this is force into perpendicular distance, which is 50 into 0.5, because we have to convert distance in centimeter. 0.5 into 10, so this would comes to 5 Newton meter. Okay, similarly at point B, so when we are concerned about point P, the distance would be this and force would be this, so it would remain same. This force is 10 Newton into 0.5 meter. When we multiply 5 Newton meter, okay, which is same. And let me delete this. Now O point. Okay, so this is the center part. Okay, we know the torque. Torque is equal to force into perpendicular distance, but it is an example of couple. Why? See, this is the center point O, this is 0.25 force in this direction, 0.25 into force into this direction, mean all of the force are clockwise. So what we can write, situated result moment. So moment is equal to 10 into 0.25 plus 10 into 0.25. This is this part and this is this part. So this comes to 10 into 2.5 plus 2.5, total is equal to 5 Newton meter. Clear? Okay. Okay, regarding question 8, a uniform meters. Okay, so this is 100 centimeter scale, is pivoted at midpoint, mean the midpoint this is 50. Okay, and a weight of 50 gram force is suspended at one end. So this force is 50 gram force, and where should a weight of 100 gram to keep it balanced? Okay, obviously the force would be clockwise, so we need to suspend some weight, some at some distance x from 50, so that it is clockwise moment is equal to anti-clockwise, and thus weight is given as 100 gram force. Okay, as we have studied earlier, clockwise moment is equal to anti-clockwise moment, so that the condition is in equilibrium. Okay, horizontal mean equilibrium. Okay, so let this distance, all the distance would be measured from the center point, so we can write it as x into 100 is equal to 50 into 50. Why we have taken 50? Because this mark is 100 centimeter and the distance from this is 100 minus 50, so this comes to 50. We have taken this, so x is equal to 50 into 50 upon 100, 52 to 25. So the distance would be 25 centimeter from center. Okay, so 8th one is clear. Okay, regarding the question number 16, a uniform meter scale rule can be balanced at 29. Okay, uniform half meter, so the scale total length is 50 centimeter. Okay, and can be balanced at 20. Okay, so the midpoint would be 25, but it is not balanced at this point, so we will ignore it. Okay, it is measured at 29 centimeter balanced. Okay, so obviously the midpoint, the larger weight will be on this side, so this is going down. Okay, 20. So the whole weight of scale would be act, as we have already studied that the whole weight of the scale act at its midpoint, which is 25, but here it is balanced at 29 centimeter, mean whatever is the weight of scale, let it be x, it is acting at 25 centimeter, mean 4 centimeter from here. So as per diagram, this would be the so this is the x and 25. Wait. So whole weight is acting, weight of scale is acting at midpoint, that is 25, and let the weight of scale is mg, mass of the scale. Okay. And to balance it, this would fall down here. So we have balanced some weight at this point, which is given as 20 gram. So this is 20 gram force. Okay, so this is the first question diagram. Now find the mass of the scale. So as we have discussed already that what is the distance between this and this, all the weight is acting, so weight on this side, mean anti-clockwise force is equal to clockwise force. So what is mass? We have to find mass into distance between them. 29 minus 25 should be equal to clockwise momentum, that is 20 into 20 weight, and what is the distance? This is 50 centimeter. So 50 minus 29. So this comes, so we can write mass is equal to 20 into 21 upon 4. Okay, there is one mistake here, but as both the weight will be in grams, so I have not converted it. Normally it is convenient that if you convert the mass in kg, okay, we can ignore, as the total final answer will be in gram only. So 4, 5 and 21 into 5 is equal to 105 gram. So that is the answer. Okay, and in which direction would be the balancing point shift if 20 gram force is shifted inside from one end? Okay, what is said that this is shifted here. Okay, this is balance here. If we multiply the distance, if we decrease the distance, then this would tilt on this side. Okay, so weight will shift, equilibrium point will shift toward this side, mean toward 25 centimeter, which is mentioned. Okay, if there has been some distance here, if we shift here, then the total momentum is equal to force into distance, and weight we can't increase, it is remain same. If we increase the distance, then this moment will increase. If we decrease the distance, this moment will decrease. If this moment is decreased, then weight will shift toward the center of gravity, that is midpoint of the scale. And next is 70. Okay, uniform is balanced on fulcrum at 40 centimeter by suspending an unknown. Okay, not an issue. This is scale uniform meter, so total length is 100 meter and it should be balanced, mean weight of the scale should be balanced at 50 centimeter, but this has been balanced at 40 centimeter. Okay, so obviously the scale weight will act this way, mean clockwise. So we have to balance this, we have to suspend some weight at the mark of 20. So this is the 20 centimeter and weight is suspended at x. Okay, find the value of mass. So weight of scale will act at 50 gram, but shifted. So whole scale weight in the clockwise is equal to mass into fulcrum distance. 50, the whole scale weight will act here. What is the distance from the fulcrum? That is 40. 50 minus 40, that is 10 centimeter is equal to. And what is the distance between these 2 points? This is mass is, let it x, into 40 minus 20. This is the distance. So 20, or we can say x is equal to 100 into 10 upon 20, 25, or is equal to 50 gram. Just check it. See, 50 gram. Okay. And to which side, if mass is moved to 10 centimeter. Okay. As we discussed earlier. Resultant moment. Moment is equal to force into displacement. If displacement is increased, then moment will shift more toward this. Okay, mean toward the 20 centimeter. Okay, see this on the side of. Okay, third, what is the resultant moment? Okay, so now in the new case, see, drawing again, fulcrum is 40, weight is acting at 50, so 100 into 10, which will remain same, and this distance is 30 centimeter. So let me check it. To which side? What is the resultant moment? Okay, resultant moment is equal to, see, this will be 1000 clockwise, anti-clockwise is equal to, what is the mass? 50 into 30, 5 3 is 1500 anti-clockwise, and what is the resultant moment? Okay, so obviously anti-clock moment is greater than the clockwise. So what is the change in result momentum? 500 Newton meter. Okay, clear? How can be balanced by another? You can consider by, obviously it is suspending here. So what we need to find? We at some point we need to suspend 50 gram weight. So what you can say that 10 into 30 into 50 should be equal to 50 into 10 plus 50 कितना weight था बेटा 100 into 10 plus what is the weight suspended? 50 gram at x centimeter from, so calculate x, and it would be this away from this. So whatever is the x coming, you will add in 40, and that would be the answer. Okay, now the final question is 18 in the figure. Okay, 1 point, the uniform bar of L is supported at and loaded by W in its, find the reaction R1 and R2. Okay, let me see what is in the, okay, it is already, okay, see this force is acting upward. Okay, and which is equal to W. Okay. So what we can say that R1 plus R2 is equal to W, because both are being balanced by this force. Okay, that's why this is mentioned. So, or we can say that as find the, okay, it is middle. So scale of weight of whole scale will be at middle. So obviously R1 is equal to R2. What this W signified, that the weight of the whole scale is acting at the equilibrium. So whatever weight is suspended at equilibrium point, it would be balanced by R1 and R2. So what is the resultant force? We can say that, see, what is the length of scale? Length of scale is L. So this is L by 2. This is L by 2. So what is the force here? This is anti-clockwise. Sorry, this is clockwise. This is anti-clockwise. So R1 into L by 2 should be equal to R2 into L by 2. So L by 2 cancel out. So R1 is equal to R2. Okay, and it is mentioned that R1 into R2, R1 plus R2 is equal to W. R1 plus R2 is equal to W. We know that in equilibrium, I told. Okay, so what we can say, instead of R1 I can write R2, or 2R1 is equal to W. R1 is equal to W by 2. R2 is equal to W by 2. So find the reaction. We got it. That's all.